Welcome to Geometry. Today we'll cover segments and segment addition. So make sure you review the vocabulary terms point, line, segment, and collinear. We're going to touch upon them during this lesson. So for instance, if we had a number line here representing the locations of Princeton High School with the letter P and the taco shop with letter T, how could we find the distance from P to T? Well, if we have them on a coordinate or a number line, we can actually hop and find that distance just by counting the times we have to move to the right. Another way is if we had coordinates, if we had real numbers on this number line, we can find the distance by using subtraction, right? So we could actually say, well, the distance between the taco shop and Princeton High School would just be T minus P, would be 16 minus 10. So 6 spaces away. What happens when we actually subtract P minus T? Well, when we subtract P minus T, we get 10 minus 16. And we're looking for the distance, so you would think we could subtract, but we get a negative 6. So it's really important to remember that for distance is always going to be positive. So to always make a number positive, we use absolute value. So again, the distance is 6. So absolute value is really important when helping to determine the distance. All right, let's go down here to find the segment lengths. Here we have a number line with points A, B, C, and D. How would we find the length of CD? Pretty easy, right? We could subtract them if we want. So D minus C, and I'll take the absolute value. 4 minus 1, that's an easy 3. You could have hopped and counted that you had to move 3 spaces as well. So the ruler postulate is something that we use every day, and you've used for a long time. So we use the word postulate in geometry when it's something that we do not need to prove. It's something that's common knowledge. So here we have the ruler and points x and y. The coordinate of x is 3 and the coordinate of y is 7. So the ruler postulate says that every point on a line can be paired with a unique real number. The number is called the coordinate of the point. Now, if you want to find the distance, well, you can subtract them, but just remember, it has to be a positive value. So that's why we use absolute value. The distance between any 2 points, x and y, is the absolute value of the difference of that coordinates. Now let's move on to something that may be a little bit trickier, but probably not too difficult for you. So we want to find the value or the distance of KL. Well, you can see K right here as with the coordinate 12 and L with the coordinate 16. So if I just did it without thinking and subtracted and made sure I used absolute value, well, I could plug that in and get 12 minus 16. The absolute value of negative 4 is 4. So here on the next one, if I wanted to find the length or the measure of JK, J is over here, I can use the same process, K minus J, and I'm going to use the absolute value. So let me write that a little bit more clearly. So K minus J, and the absolute value of those, if I substitute in for K, that's 12. J is 5. 12 minus 5 is negative 7. And the absolute value of negative 7 is just 7. Okay, for the last part, we can add pieces of the segment together to be the larger part. But there's something really important. If you're using segment addition, and this is a segment addition postulate, you have to have 3 points that are on the same line. And B, this point right here, has to be in between A and C. And if that's true, then you can say AB plus BC equals AC. Okay? So looking down over here, we have another segment. And I'm going to do a couple things first. Okay, so if we have this segment, F, G, and H are points that are collinear on the segment, or on the line, I should say. If we want to add these segments together, well, we know FG plus GH equals FH. So we want to figure out the length of FH, right? And there's a couple things that we can do. We can add them together, right? So if we add these two segments up, we'll get FH. And then if we know what the value for GH is, right here, we can figure out the value of X. So I'm going to first write FH in terms of X. So looking at this one, we know that FG is 3x minus 1. And we know that GH is 2x plus 2. So if I want to simplify that, I can get the length of FH with the variable x. So combine like terms, 3x plus 2x makes 5x. And then 2 plus a negative 1, or 2 minus 1, would be plus 1. And I'm just going to rewrite it. So FH equals 5x plus 1. Well, I still have that x, and we have to figure out what x equals first. So I'm going to actually go back to GH. We know that GH, this one, equals 16. So if I say 2x, let me write this first. GH equals 2x plus 2. And we're given that that equals 16 from the top here. So if I just focus on this part right here, I can solve for x. So I'm just going to erase that for a second so it's not really confusing. So to solve for x, remember we have to get x by itself. So I'm going to subtract 2 from both sides. So we get 2x equals 14. And then I'll have to divide both sides by 2. So then my variable x equals 7. Well, if I know that x equals 7, I can use this information for f of h. So if f of h, or fh, equals 5x plus 1, well, I could plug this value in for x. So that'll be 5 times 7 plus 1. And that's going to be 35 plus 1. So FH, that length, must be 36.